The National Center for Adaptive Neurotechnologies is a research and development center set up by the National Institute of Biomedical Imaging and Bioengineering of the National Institutes of Health. And the goal of the center is to develop new basic science advances in neuroscience and neurotechnology, and then translate them into practical applications, clinical applications, research applications, and then to disseminate this expertise, these methods to other scientists, to other engineers and clinicians throughout the world. The center is the product really of a unique set of circumstances that are really probably only possible at the Wadsworth Center, which is part of the New York State Department of Health. We've been able to assemble and keep a group of very talented investigators.
The purpose of Adaptive Neurotechnologies is to develop new avenues for interacting with the nervous system to cure diseases or to diagnose diseases.
Through interactions with the world, the nervous system can change in many different ways throughout life. This is something that was really not understood till very recent decades. So this introduces all sorts of possibilities for restoring function, for improving function for people with spinal cord injuries, for strokes, with other disorders. And at the same time, we now have technology which allows us to interact, to set up these interactions in real time, in very complex ways, to induce and guide central nervous system plasticity to improve function.
About 10 years ago, it would have been really difficult and expensive to develop the technologies that are necessary to interact with the nervous system. These technologies have become pervasive, cheap, easy, which opens a huge opportunity for developing technologies that actually address important problems.
So the core of the center are three technology research and development projects that start with basic science and develop that into technologies that serve useful purposes. The first area is looking at the ability to change very simple spinal cord reflexes. This is something that we first demonstrated, and we've now looked in considerable detail at the basic mechanisms of it. We're looking at the mechanisms of what happens when we change reflex pathways, both in normal rats and in rats with various kinds of disorders. We're looking at what happens anatomically and physiologically in the spinal cord, how this interacts with the brain, how the brain induces and guides change in the spinal cord. It's becoming clear that there are complex hierarchies, patterns of change that occur in the brain and in the spinal cord for even the simplest kind of learning. So we're exploring that with a particular focus on developing its therapeutic applications. And the work that's going on in rats is being transferred into humans, and that to some extent has already occurred to help people with various disorders. For example, this work, which began in rats, is now helping people with spinal cord injuries to walk better.
The first thing I noticed was an increase in my speed. It's still not of a typical healthy person, but I'm definitely able to carry my leg through more consistently, smoother. I used to really try to rely on a hip flexor that I don't have to try to walk, and I've learned to recruit other muscles that I didn't even know I was capable of using.
Our second research and development project focuses on brain-computer interfaces, which are systems that record brain signals and convert them into various kinds of outputs. For example, they can allow people to communicate and control things like a robotic arm or a prosthesis. So they can be very useful for people who are paralyzed. Also, we've been using them more recently to develop new means for rehabilitation, to improve function in people after strokes, for example.
My role here in the Brain-Computer Interface Project is to translate the technology into a practical, usable format, and to see how people can actually use it in their homes for practical value.
In the third research project in the Center for Adaptive Neurotechnologies, we're developing new technologies that allow us to study the brain better then use those technologies to derive new understanding about the brain, and then use this new understanding to develop new diagnostic and treatment options. It's been increasingly recognized that brain processes are very complex. They don't occur at a single location at a single time. They actually occur at multiple locations at multiple times. And as of yet, there are really not very good ways to characterize in detail the spatial temporal progression of those processes. In preparing patients for surgery for epilepsy or a brain tumor, surgeons routinely place electrodes on the surface of the brain to localize important brain areas. While these electrodes are in place, they can be used to study brain function. The surgeon places electrode grids like this one. The electrodes sit directly on the surface of the brain and are recording activity from neurons immediately underneath them.
So when we do our recordings, we tap into those signals, and we also add additional behavioral measures. So sometimes we're interested, for example, in what you say. So there were to be a microphone that picks up your voice. Or we are interested in how you control your fingers. So there's then a data graph that picks up the flexion of each of your fingers.
In our translational research, we're then using this understanding to allow clinicians to identify those areas in the brain that are responsible for a particular function. There's
lots of progress made in the sensors. There are better sensors, more tightly spaced, better implantation procedures. We have a better understanding of those signals that we record. We understand more the interactions between different frequencies, for example, in these signals. So compared to like 10 years ago, we are now in a much better situation to actually make use of electrocardiographic signals and to actually develop clinical applications that provide value to people and clinicians.
So that's the core, that's the research and development core of the center. The other part of it is the training and dissemination part, where we take these technologies and we educate other people in their use, and we disseminate protocols, we disseminate standards that either through print or online or through training courses and workshops, so that other people can also become competent in these areas.